This is MATHguide.com, and my name is Mark Karadimos. In this video, we're going to solve quadratic inequalities, and we're specifically going to look at the technique called graphing. So we will be using a graphing calculator to do this. So in this video, we're going to have two examples. Okay, let's get started. All right, we have example 1. And I'm pulling the same examples that I used when I solved these inequalities using the technique called algebra. So there is a way to solve these inequalities by using algebra, and you can always check out, of course, our other video to do that. However, for this method, what we're going to do is use the technique called graphing, and in order to graph as your technique for solving this inequality, what we're going to do is pull up a graphing calculator in a moment, and we're going to graph this function and this function separately. So I'm going to call this function 1, and I'm going to call this function 2. Oops. And what our hope is determining where these two functions intersect. Okay, so when we find the point of intersection between graphing these two functions, those we'll find the critical values by doing that. And then once we find those critical values, we'll then see how to use this inequality to find the set of answers that are going to work, not just our critical values. All right, well, let's actually go through this. There's a lot of theory, and unless you see it in practice, it doesn't mean much. So I'm going to throw into the calculator these two functions. All right, I'm using a TI Inspire calculator. I'm going to get a new document. I'm going to go to Graphs. And of course, the standard window appears, and it's asking me for a function. So again, I'm putting in the left side. So I'm going to put x squared, and then I'm going to put a minus 18. And of course, this is going to be our first function, and of course, it's going to graph it. And it's no surprise that this is a quadratic. It's a U-shaped graph. We knew that by looking at the square. Okay, let's also now graph the second function. So for this calculator, I hit tab. Now it opens up our second function, and I'm going to put in 3x. Press enter, and it gives me a linear function. Again, no surprise there. I want to find out where they intersect. So I need to expand out a little bit, need to see more of the graph. So for this calculator, I get to zoom out. Okay, and I'm going to zoom out one more time. There you have it. Okay, so now you could see very clearly that the blue quadratic, that's the left side of our graph, crosses the red right side of our graph, our linear function, at these 2 points. Now we want to find those 2 points. So what you do with this particular calculator is you go to Analyze Graph, you find the intersection. And I want to find this point. So it says, where's the lower bound? In other words, I go left of it. I go left of there, and I'm going to press the center keypad, scroll to the right, and you can see that I get this point. Okay, so let's get the other point over here. So again, I'm going to go to Menu, Analyze Graph. I'm going to go to Intersection. I'm going to go to the left of it, press my center keypad, scroll or use your keypad, go to the right, and we get our other point of intersection right there. Okay, so those 2 points are very important because they give us our critical x values. You can see that I've got an x value of 6 on the right side, and I've got a x value of -3 on the left side of this graph. Okay, in other words, those are the 2 x values that are critical. And that's something that we should write down or remember. So I'm going to do that. I'm going to go back to the original screen. I'm going to write that down, -3 and 6. All right, so on a number line, I'm putting down -3 and 6. So 0 would be somewhere around here. And of course, that's where it's equal. So of course, these are solutions to the problem. Okay, now the question is, which region is the correct solution? Is it all the values between -3 and 6? Is it the values right of 6? Is it are it the values left of -3? So we got to figure out where are the solutions, the shaded areas as we speak. Okay, so let's go back again to the graph, keeping in mind that I have this greater than sign. I want to know really where the quadratic is greater than the line. Okay, because this is the quadratic, this is the line. So where's the quadratic greater in height than the line? Okay, so let's look at that. Now, if you look closely at this graph, you're going to notice that we have the curve and we have those critical values, and you'll notice that between the two critical values, the quadratic, the blue-shaped curve, is lower than the graph. Okay, that's not what I want. I don't want where the quadratic is lower than the line, right? I wanted to know where's the quadratic greater in height than the line. So if you look over here to the left of this critical value, you're going to notice over here that the blue curve, the quadratic, is greater in height than the red line. And also over here to the right of this point, you'll notice that the blue curve is higher than the line. So that's where our answers are. Okay, so we just found the spots where the quadratic is greater in height than the line, to the right of 6 and to the left of -3. And there we have it. So the solutions are values that are to the right of 6 and values that are to the left of -3. This is what it looks like graphically, and we could write this as inequalities also. We could say that these are the values x that are greater than or equal to 6. These are also the values x that are less than or equal to -3. Okay, so we have either this or this. Those are the solutions. They're written as inequalities. Okay, let's go on to our second example. All right, let's get to our second example so we can see our visual representation of this problem. So let's write this down first. Plus 7x. Okay, so here I have a quadratic inequality, and we're trying to solve this. We're going to use method of graphing once again. So what I'm going to do, of course, is plug into the calculator these two functions. So here I have f1 of x, which is, of course, a linear function. And over here I've got f2 of x, which is a quadratic function. So we're going to see a line and a u in a moment. Okay, let's check out our graph. All right, I already took the liberty of pulling up a graphing application on my TI Inspire. So now what do? We hit tab to insert our first function, which is just plain old 4. Press enter, and we've got our line, which we expected, a constant function. Okay, now let's go on to the next one. Hit tab again, and now let's put in 2x squared. What was it? Plus 7x. Plus 7x. Okay, press enter, and we see the u. I'm just going to move this out of the way here for a moment. Okay, so we got our second function, we get our first function. Everything looks pretty. Now we want to find these critical values where the blue line crosses the red curve. So we go to Menu, Analyze Graph, and we're going to go to Intersection. Okay, so what we do is we go left of this point, click our center keypad, scroll to the right, and we get our critical value there. And of course we do this one more time on the right side. So again, I'm going to go to the left of the point, scroll to the right, and there you go, I've got another point. Now remember, our original equation just had x's in it. I don't really care about these y values. I'm not interested at the moment. So for our critical values, we just grab the x values, which are -4.5. Okay, so -4.5, let's put that in a graph. All right, so on a number line, I'm going to put -4.5, which I could write as a fraction. Okay, and of course we know that 0 is going to be somewhere over here. Now there is no equality here, so these critical values are really not part of the answer. Because there's no equal sign, I use an open circle. Okay, use one right over here too. All right, now what we're going to do is use this greater than sign to figure out where the answers are. Okay, I want to know where this line is greater in height than the quadratic. Okay, so that's what I'm looking for. Where is the line higher than the U-shaped graph? Okay, let's go back to the graph to see that. All right, so you'll notice that we've got this line, and we got the U shape, and I wanted to know again, where is the line higher? So if you look towards the center of the graph, this U shape goes very low, way lower than the line. And there you go. That's where the line is higher than the U-shaped graph. On the right side of the graph, the U is higher. Okay, I want to know where the line is higher. See how the line is very low and the U is high? That's not where the solution is. Here we get the line that's low and the graph is really way up there in height. So this is the only spot between our two critical values where the line is higher than this U-shaped graph. And there's your answer. Your answer is between the two critical values. So let's go back to our number line. Okay, returning to our number line, that means we're going to shade all this in between the two critical values. So I'm going to shade all of this material on the inside. And there you go. There's our solution. So these open circles are not part of the solution, but everything else is. Okay, so how do I represent this using inequalities? I would say that these are all the values that are less than a half, but greater than -4. Okay, and there you have it. There's your inequality. Sometimes people write it separately. They say these are all the numbers that are less than a half, and these are all the numbers that are greater than -4. And they write them as two separate inequalities. But I'd rather flip this one around, put it right there. And when it's in the middle, you can do this because you're satisfying two requirements at the same time. It's less than a half and it's greater than -4. Anyway, that's the more preferred way to write that. Okay, make sure you go back to MATHguide.com, check out our text-based lessons, our interactive quizzes, and of course our instructional videos. Take care.